Swayam Prabha. Digital India. Educated India.
The next basic element is the inductor. It's given by this symbol which resembles a coil. This is because inductors are frequently implemented as coils of wire. And again, we define V and I using passive sign convention. Okay. Now it turns out that the voltage across an inductor is related to the flux linkage stored in the inductor. Okay. It's given by this relationship where this psi is the flux linkage and psi itself is proportional to I through a proportionality constant which is known as the inductance. Okay. So the inductance is measured in henries or H. Now you can see that this relationship is analogous to charge being proportional to voltage. Here the flux linkage is proportional to current and the current was the rate of change of charge, whereas the voltage is the rate of change of flux linkage. Okay. So you can make this kind of analogy between quantities in a capacitor and in an inductor. But this flux linkage is a little more abstract quantity than a charge, and I won't go into the details of it. But from the geometry of the inductor and the current flowing in the inductor, you can find the flux linkage. But again, we don't have to go into all those complications because, as I've emphasized repeatedly, we are interested only in the terminal characteristics. Okay. So that is the relationship between V and I, and for that we can eliminate this flux linkage and get a relationship which is V is L, the inductance, times the rate of change of current. Okay. So this is the defining relationship of an inductor, where again V is defined with this polarity and I with that polarity. Okay. So the inductance, as I mentioned earlier, is measured in henries. So what does this relationship say? If the current is increasing at the rate of 1 ampere per second and if the inductance is 1 henry, the voltage across the inductor will be a constant which is equal to 1 volt. Okay. So one point I would like to caution you about here is that all of you would be familiar with Lenz's laws from physics, and you would know that the induced voltage across an inductor is in a direction such that it opposes the change in flux and so on. And it's common to see relationships like V is minus L di by dt. Okay. Now don't be confused by that. This is the correct relationship with this particular sign convention. Okay. Now it turns out that in most of the physics books, the current would be considered in the other direction, and that's why you get a minus sign in that expression. Okay. Now, if you have V like this and I defined this way, this is the relationship and this is the induced voltage which opposes the change in magnetic flux linkage inside the inductor. Okay. So what does this say? V is L times di by dt, and if I is changing at, let's say, 1 ampere per second, and if the inductance is 1 millihenry, clearly voltage induced across it is 1 millihenry times 1 ampere per second, which is 1 millivolts. Okay. So the voltage across the inductor is 1 millivolt. Now this also says another thing. It says that if the voltage across the inductor is finite. Okay. The current through the inductor cannot change instantaneously. Okay. So clearly that's apparent from this relationship. If the current changes instantaneously, the time derivative is infinity and the voltage would have to be infinite as well. Okay. So this is analogous to the voltage in a capacitor, which also cannot change instantaneously if the current through it is finite. Okay. Now we have V is L di by dt, which says that I is 1 over L integral of the voltage with respect to time, and I at time t1 is given by this integral plus I at time t0. So that means that the difference in currents at time t1 and time t0 is given by the integral of the voltage, the area under the voltage curve, divided by the inductance of the inductor. Okay. So this again is analogous to the relationship we saw earlier with the capacitor. Now clearly, the current in an inductor at a given instant depends not only on the voltage at that instant, but on voltages at all previous instants. So again, just like the capacitor, an inductor is also an element with memory. Okay. The capacitor stores charge and inductor stores flux.